here I'm asked to solve the inequality and give a verbal description of the answer. Okay, question A. The absolute value of 1/12 x minus 1/2 in absolute value is less than 1/6. The first thing I notice is that the absolute value is already isolated. There's nothing multiplied by the absolute value or being added or subtracted to it. So I can set up my two inequalities. I'm going to have 1/12 x minus 1/2 is less than 1/6. And because it's less than, I know that this is an and statement. Less than and. Notice that when we have less than, the less than symbol, and the x is over here on the left of an absolute value, we're going to have an and statement, and the graph is going to look like this. Well, in our case, the circles are going to be open because it's less than without a bar underneath it. There's no bar underneath here. So this is what the graph should look like, and the verbal is going to be and because of this less than symbol. Unless it's a special case where there's no solution, in which case that's something we're not going to get into right now. So 1/12 x minus 1/2 is less than 1/6, and 1/12 x minus 1/2 is greater than negative 1/6. Notice in the second inequality, I flipped the inequality from less than to greater than, and I changed this sign from 1/6 to negative 1/6. Okay, so I have all these fractions, and it'd be nice if I could get rid of all these fractions. The first thing I'm going to do is find the largest number in the denominator, which is 12, and I'm going to multiply everything through by 12. So, let me scoot this over just a little bit. I'm going to multiply the left side by 12, and I'm going to multiply the right side of the inequality by 12. 12 times 1/12 is just 1, so this is 1x. 12 times 1/2, so this is minus 12 over 2, which is just 6, is less than 12 times 1/6 is just 12 over 6, which is just going to be 2. So this is x minus 6 is less than 12 divided by 6, which is 2. Okay, that simplified things up quite nicely. I can just add 6 to both sides, and I have that x is less than 8. And, so x is less than 8, and we need to do the same thing over here. If I multiply through by 12, the only thing that's going to be different from this equation to this one is I'm going to have a negative 2 right here. So I multiply through by 12, this still becomes 1x. I'm going to write this as minus, I'm still going to have 12 over 2, which is just 6. This is still going to be greater than. And now I have negative 1/6 times 12, which is just going to be negative 2. And I add 6 to both sides, and x is greater than, I have 6 minus 2, which is 4. So x is less than 8, and x is greater than 4. So to get a visual of this, even though the question does not ask for a visual, here is 0, here is 4, here is 8. Our solutions, I'm going to put in red, if I circle here at 4 and circle here at 8, because 4 and 8 are not a solution, it has to be less than 8 and greater than 4, our solutions are right here. Okay, now for the actual answer to our question, a verbal description would be x is less than 8, and this is important, the and, x is greater than 4. Okay, this was the answer we were looking for. A verbal description of the solution. And notice that a lot of students want to think that 8 and 4 are the solutions. They're in fact not a solution to this inequality. There are multiple solutions to this inequality, and 4 and 8 are not one of them. However, a number like 5 right here, well, it wouldn't be exactly in the middle, but 5 would be a solution. A number like 6 would be a solution. 7 would be a solution. but 4 and 8 are not solutions, and I'll leave that to you to figure out why they're not solutions. Okay, let's look at the second question we have here. We have the absolute value of 1/20th x plus 1/5 closed absolute value is greater than 3/2. Now notice we have the greater than symbol here, and we're reminded that when the absolute value of x is greater than a number, then we have an or statement. So this is, the verbal is or, and unless it's a special case, our graph will look like this. It'll have arrows going this way, away from each other. Now if it's a special case, this is the one where you can have infinitely many solutions, but we're not going to discuss that right now. First thing we notice is our absolute value is isolated, so I can split it up into two inequalities, and that's 1/20 x plus 1/5 is greater than 3/2, or, this is key, or, because it's greater than, 1/20th x plus 1/5 is less than negative 3/2. Notice when we split it up to two inequalities, we no longer have the absolute value symbol. I've noticed a lot of papers coming in, when they split it up, they still have the absolute value symbols at this point. That's not correct. Okay, the number we're going to multiply through by is 20. It's the largest number in the denominator, and let's see if that clears things up for us nicely. So I'll multiply the left side by 20, left side of the inequality, and I'll multiply the right side of the inequality by 20. Distribute this 20, and I have 20 over 20x plus 20 over 5 is greater than 20 times 3. Well, that's 60. 60 over 2. Okay, we can simplify this up quite a bit. 20 divided by 20 is 1, so this is just 1x. I can just write that as x if I'd like. Plus 20 divided by 5 is 4, is greater than 60 divided by 2. Well, that's 30. 30 times 2 is 60. Okay. We can solve this rather easily. We subtract 4 from both sides, and that's pretty much it. X is greater than 30 minus 4. Well, I think that's 26. 26 plus 4 is 30, so 30 minus 4 is 26. So x is greater than 26, or, and notice that was the result of this greater than symbol, or x is going to be less than some number, and let's find out what that number is. If we multiply through by 20, again, it's going to be the same as this, except for I'm going to have a negative sign right here, and it's going to result in x plus 4 is less than negative 30. But I'll verify that for you. If I multiply everything through by 20, I have 20 over 20x plus 20 over 5 is less than 20 times 3 is still 60, but this is negative 60 over 2. Everything stays the same except for I have x plus 4 is less than negative 30. And if I subtract 4 from both sides, this time I'll have x is less than negative 34. So x is greater than 26, or x is less than negative 34. Let's go ahead and get a graph of this to see what it looks like. So right here is 0. 26 would be, roughly over here. 26, and it's greater than 26. Greater than with no bar underneath, so it's an open circle. And then I have negative 34 over here. Open circle. Just like that. And that's the graph, but the actual answer asks for the verbal description. And the verbal description has to use the or. So we have x is greater than 26, or less than negative 34.